Hello everyone, I'm Thomas and this is day 6 of 100 Days of Code in IoT Challenge. Today, I'm gonna continue on the yesterday's subject, which is building a circuit with the relay module to improve this mocha style pressure coffee maker, right? To make it switch off automatically after 10 minutes. However, before we get back to what I've been doing yesterday, let me show you this warning message because today I'm definitely still gonna be dealing with the high voltage. Okay, so here we got the code and now let's modify it because we basically want to wait. Ultimately 10 minutes. But basically what we could do here is to just use delay function. And that would be like, something like that to wait for 10 minutes, right? This is basically 1000 milliseconds times 60 seconds times 10. That gives us basically 10 minutes in milliseconds. The issue with delay though is that this is a blocking operation. So in our case, I think that could work. And it could actually prevent the situation where someone presses the button after 5 minutes, and then the time is added, the waiting time is added to it. This is not gonna happen if we block everything using delay. However, this is not really a good solution for the future. Again, the reason is it is blocking. So by blocking, there's nothing you can actually do in the meantime. So if you wanted to, let's say, read the time left, it's not possible with delay, right? So instead of delay, I'm going to introduce a new function here, and that function is called millis. And that actually gives us a time in milliseconds since the start of the device, since the boot, since the setup execution, right? Or in other words, right, since the power has been supplied to microcontroller, right? So as soon as the power is supplied, it starts. It's like a counter, but in milliseconds. Right, so that gives us a number in milliseconds, and what we could do is to set a variable. Let's just go. Let's just call it maybe. I'm going to explain why unsigned long type. Let's just call it coffee ready time. All right, so you got this variable. It is like global, so there's going to be access to it from the loop function. And the reason I put unsigned long is basically that if you click through to the millis, right? I just press my command button. You can do the same with the control button on Linux or Windows, and you should see actually what is the return type of millis, which is unsigned long. So it's basically big int. It's the reason actually is because this is counted in milliseconds, right? We don't want to the counter to go to zero, because this is essentially what happens when you reach the end of the limit on integers, for example, right? It just goes back to the first value. If you use unsigned, which is only positive numbers, it's gonna start again from 0. Right, so we really want to, they wanted to avoid this. It still can happen, but with unsigned long, it's just longer time until it happens. Okay, so this will be our coffee ready time, and in order to actually set this value correctly, what you're gonna have to do is when we switch on the relay here, so this is where we're switching on the relay, we want to set this coffee ready time to the value that is like sort of in the future, right? So we have millis that gives us a current time, the time now, right? It's not the actual time, right? It's just the number of milliseconds from the beginning, from the start of the device. But this is fine. It's the actual time, the number of milliseconds, and we want to add our 10 minutes here, right? That would be our 10 minutes here. So by doing that, we're setting a time in the future, right? And having this set, we can have another if here that checks if this time is less than the current time, right? So that always gives you, like, you know, current number of milliseconds. This, when it's already set in the future, right? It is like something in the future, right? So let's say I set this for, let me just use maybe smaller values. So we say 10 seconds instead, right? So we started this, and let's say it's just 1000 milliseconds already passed from the beginning. So by setting the coffee ready time, we're gonna set it to basically 21 milliseconds, right? Right after that, in the same loop call, this is gonna check if the actual time is greater than the coffee ready time, right? So it's gonna compare this 1000 with this 21,000, right? And basically this is false, so it's not going to be executed. So that's the idea, right? And what I can do here is basically say relay off when that happens. Okay. So yeah, one thing to notice is basically when we don't set a time at the beginning, like just by declaring this variable, we're setting the value actually to 0. So this will happen right after it starts, right? Before we press the button, because yeah, this basically happens only when the button is pressed. And that would happen all the time. So we would keep setting digital right all the time. We don't want to do this. So how can we prevent this from happening all the time? We can use digital read, right? We can use digital read on the relay. And we can check if this is high. That means the relay is on, right? It is switched on. And when the relay is switched on, and it's a time for switching off the relay, right? This is basically saying that. Then we want to switch the relay off, okay? Okay, I'm going to make this code a little bit simpler, like to read. So in order to do that, let me just introduce some additional functions. So basically this one, digital read, okay, maybe we start from the pins. Okay, so we have D5. D5 doesn't tell us anything at this point, right? So let's define two new constants, and let's call it relay pin, and that's gonna be our D1, and let's do not relay, that is going to be button pin. And button pin is D5, right? So now we know that, you know, D5 is basically button pin, so I'm going to replace it here. And then we have our relay pin, which is basically D1. I'm going to replace it here. So it's going to be easier to read. Another thing, because yeah, this can be a little bit misleading, like because we use input pull up. Let me just replace this as well. Yeah, because we use pull up, the initial voltage is high, so that can be also misleading, like why we're checking whether this is low, right? So I can introduce another function. I'm just gonna say is button pressed, and if the button is pressed, this is gonna return boolean, right? If the button is pressed, it's going to return true. So that's going to remove the confusion from here, right? So I'm just really gonna return this condition, this comparison result, which is a boolean here. So I can say if button is pressed, right? I really want to say switching on the relay. That's what I'm doing, right? And this happens here. And then we set the time in the future to switch it off. And now for this part, right? Again, we can have another boolean function, and we can say is relay on, right? So by making use of functions, you can make the code more readable, right? We're just doing this really, but it's easy to read for someone, right, who looks at this code for the first time. Not like this. Okay, yeah. So now we're checking like is relay on, and we're checking the coffee ready time. I could even this could also be like is coffee ready, but for now I think this is enough. So if we say if is button pressed, then we do that, which is basically we're switching on the relay. We can have another function for that, right? So switch on the relay. That is void because it doesn't really return any value. Right, so we can do this here and say switch on the relay. Right, so it's more verbose now, right? Is button pressed, switch on the relay. Is relay on and the coffee time is ready, it's basically it's coffee time, then switching the relay off, we could have like, you know, switch off the relay. And that we can move here. And we can say this, right? Switch off the relay. Easier, right? Another thing I need to add is basically for the button pressed. At this point, if we keep the code like this, let's say we press the button, it's gonna switch on the relay, right? And that just sets the time, right? It happens here, right? It sets the time in the future. We release the button, everything's fine. And let's say after 1 minute, right? It's 10 minutes waiting, but after 1 minute, I'm gonna press the button again. What's gonna happen? This function is executed. And when this function is executed, it's going to set a new coffee ready time, right? So that's something like in microwave, right? When you add another 30 seconds, we don't want that. We don't want that for our coffee maker. So in order to prevent this kind of behavior, what I'm gonna do is to check if the relay is off, right? So let's add another boolean function, and I'm gonna ask if is relay off, and that is going to basically just return the opposite of relay on, right? It's just gonna be opposite, right? So if relay is not on, right, we say true, this is off. And that is gonna be something here. So I'm gonna say is relay off and is button pressed. So only if relay is off, the button is pressed, we're switching it on, right? And then if relay is on, or is on, and this is a coffee time, we're going to switch it off. Okay. So yeah, this is essentially it for the code. And now, you know what? Before actually we move back to the circuit, I'm going to code the behavior of the buzzer as well. So I'm gonna add another pin here. Let's say this is gonna be D2. So we say buzzer pin D2. We need to set the mode for this one to output. Buzzer pin, come on. Yeah, so we have buzzer pin now. And what I want to do is basically introduce here another function to switch on the buzzer. Switch on the buzzer. We don't want this to be switched on all the time once the coffee is ready, because the sound is really annoying. So this is just gonna be like, I guess 5 seconds. Let's give it 5 seconds for generating the sound, and then it's gonna go off. So it's more like notification than the actual, let me just fix indentations. I'm just thinking, we should have this automatic. I'm gonna look into the C-Lang. In the C-Lang plugin here in a second, because it's not working as it's supposed. It should be auto-formatted. Everything should be auto-formatted here. But yeah, anyway, let's just do it quickly. So switch off the relay, and we want to switch on the buzzer. And to switch on the buzzer, I'm just gonna say switching on the buzzer, right? Not the buzzer pin, the buzzer. And this is just gonna be digital, right? And we say buzzer pin. We're gonna set it to high, and we actually run in the same sort of problem that we did with our relay, right? Because that needs to happen in the future again. This is gonna be shorter time than 10 minutes. Actually, we have 10 seconds here. I'm gonna have to change it to 10 minutes. But for the sake of demonstration, we're just gonna keep 10 seconds here. However, for the buzzer, let's just do the ultimate waiting time. So for the buzzer, we need another unsigned long buzzer. Let's just call it buzzer off time, maybe buzzer off time. Again, unsigned long, and just quickly on the buzzer, let's just set it in the future. So that's gonna be our millis plus, and this is gonna be just 5 seconds. So 5 seconds, and here we just say if we need another function to check if the buzzer is on, right? So bool, not bool, just bool, is buzzer on, and they're just gonna say digital read buzzer pin equals high, right? So we have is buzzer on. So if is buzzer on, it's a bit slow, and buzzer off time is less than milliseconds, we want to switch it off, right? Switch off the relay, switch on the buzzer, switch off the buzzer. And let's just do it quickly. So digital right buzzer pin low, and we say switch off the buzzer. There's something wrong with the code hints in Visual Studio Code today. I think I'm going to have to restart it, because there's something doesn't like. Okay, I'm gonna compile it quickly now. Just compiling to check if everything is right. Okay, and now let's deploy it. In order to deploy, I just need to connect the USB to my computer, and yeah, I'm just gonna deploy it quickly. It needs a few seconds to recognize this. Okay, yeah, it found the serial port. Okay, yeah, deploying. Okay, it's ready. So yeah, let's have a look at the breadboard now. Before I connect the external power supply, let me just test it with the microcontroller connected to the USB. So what I'm going to do first, because like if I connect USB here, it is going to be a little bit. 1 second. This is going to be a little bit hard to actually press this button. As you can see, this cable actually blocks the way. So what I'm gonna do is to move this button a little bit. So yeah, I'm just gonna move it here, right? Just gonna move it here. And along with that, what I have to do is basically move this cable. Right, that's still gonna go to minus, and that is going here. And I'm going to move, where is this cable? Here, right? So it was just moving. And yeah, let me just connect the USB cable here. I need to do actually like that. Okay, so this is connected. Okay, so yeah, as I said, now there's not going to be any external supply. One important thing here, I disconnected those just for now, because yeah, we're not using external power supply, but the ground, we still want the ground to be connected here. Alright, basically to capture the ground from here. Okay, so yeah, I just switch it on, and we should see information here from the serial monitor. So when I press the button, yeah, we are actually getting switching on the relay. It is 10 seconds now. Okay, yeah, relay off after 10 seconds. Oh yeah, there is one thing missing, you see, so it's actually good to do some debugging, right, with the serial monitor before we actually gonna going to test it with the external power supply, right? So relay is off, but we don't see the buzzer. Yeah, the reason is basically we don't switch on the buzzer. So we have to have switch on the buzzer here. Okay, and for switching off the buzzer, I am going to add, so we say, yeah, switching, let's call this switching relay off. And for the buzzer, we have switch off the buzzer, and let's add serial println, and let's say switching off the buzzer. All right, so that is going to be a little bit better. And now I'm just going to deploy it. Okay, that's deployed. The serial monitor connected, and now I'm going to basically press the button here. So let me just show you. Oh, okay, I'm pressing it. Yeah, we have switch on the relay. We should wait 10 seconds. After 10 seconds, we should see, yeah, switching relay off and switching on the buzzer, and that should be 5 seconds and switching off the buzzer. So yeah, from the serial monitor point of view, everything is working well. Just one more test. I will try to press the button twice. So just pressing it once. And I'm just gonna do it again and again and again and again and again. A few times. And let's see. Okay, yeah, that seems like the time didn't add up, which is great. Okay, so that the initial test is working with the serial monitor, and now I'm going to connect the external power source, and let's see if the diode goes on. And also, I'm going to connect the buzzer, because now, yeah, we basically sure this is on D2. Right, so I'm gonna connect the buzzer to D2, and yeah, let's just test it with the low voltage circuit on the diode. However, once this is working, I'm gonna connect the cable that is gonna be used with the coffee maker. Okay, sorry to interrupt, but I'm gonna finish for today. Thanks for watching. Tomorrow we're gonna test the circuit with the external power supply. I also try a different power supply, and at the end we're gonna test the circuit with the actual coffee maker. So yeah, if you don't want to miss that video, subscribe to my channel. If you have any questions or feedback, leave the comment. Cheers, bye.